This video is going to show us how to determine what type of function we have and then use that information to help write an equation. The question says, determine the type of relationship shown in the table below. Explain how you know. Then, find the standard form equation that satisfies all the ordered pairs given. So first I need to use successive differences in order to determine the type of function. Remember, successive differences, we're subtracting our y values and we're doing bottom minus top. So when I go ahead and subtract these y values, I'm going to get 11, 9, 7, and 5. They're not constant, so I need to continue this process. I'm going to get 2, 2, and 2. So since I have second differences that are constant, it's a quadratic function. So I'm going to write that to answer the first part of the question. So the relationship is quadratic because the second differences are constant. Now, that's the first part of this question. The second part now wants us to write the equation. So if I know that I have a quadratic equation, a standard form equation for a quadratic is y equals ax squared plus bx plus c. So I now need to write this equation, which means I need to find out what's a, what's b, and what's c. So if we take a look at our table, you're given the point 0, 4. The point 0, 4 is your y-intercept, because a y-intercept is whenever x equals 0. So my y-intercept is 4. And in our equation, c will always be the y-intercept, which means I now know one of the three letters. So I'm going to fill that in so I have it. So I have y equals ax squared plus bx plus 4. So now I'm going to find a and b. What I'm going to do to find a and b is I'm going to pick two different points from the table and use them to substitute in. So I'm going to start with the point 1, 9. And if we know anything about points, we should remember that this is an x and this is a y. So I'm going to use the equation y equals ax squared plus bx plus 4, and I'm going to plug in for x and y. So 9 equals a times 1 squared plus b times 1 plus 4. So I'm going to get 9 equals a plus b plus 4. And we're eventually going to be solving a system of equations. And with systems of equations, we're used to seeing the variables on one side and all the numbers on the other. So I'm also going to subtract over this 4. So I have 5 equals a plus b. And I'm going to call this equation number 1. So I'm going to hold off with equation number 1, and now I'm going to do the same thing. I'm going to repeat this process with a second point. So I'm going to go back up to my table, and I'm going to look at the point 216, and I'm going to do the exact same thing. So using that same equation, y equals ax squared plus bx plus 4, I'm going to substitute in once again for x and y. This time y is 16 and x is 2. So I have 16 equals a times 2 squared plus b times 2 plus 4. So let's simplify this a little. 16 equals 4a plus 2b plus 4. Then once again, we're going to be solving a system of equations, so I want to move that 4 over to the other side. So subtract 4 on both sides, we end up with 12 equals 4a plus 2b, and I'm going to call this equation number 2. So now that I have two equations, both equations have an a and a b in them. So I am going to solve the system of equations using equations 1 and 2. So I'm going to stack them on top of each other. 5 equals a plus b, and 12 equals 4a plus 2b. Right now, neither my a's or my b's cancel, so I'm going to multiply my top equation by a -2, which means each piece inside gets multiplied by that -2. So that new equation becomes -10 equals -2a minus 2b. The second equation I'm not changing, so I'm just going to recopy it. Now I'm going to add these two equations together. -10 plus 12 gives me 2. -2a plus 4a gives me 2a. And my -2b and positive 2b cancel out. So I'm going to divide by 2, and I get a equals 1. So now I want to find b. So I'm going to go back to that equation 1, which said a plus b equals 5, and I'm going to plug in for a to solve for b. When I do that, I get b equals 4. Now remember the goal. The whole point of this question was to write the equation of the quadratic function. And we said that it had the general form ax squared plus bx plus c. Earlier we said that c was 4. We now know that a is 1 and b is also 4. So my last step is just to substitute in. So we get y equals x squared plus 4x plus 4. And that's the equation for that set of ordered pairs, or that table that was given. Remember, you can always check your answers two different ways. You can use quadratic regression, which is in a different video, or you can type this equation into the y equals on your calculator, hit second graph to look at the table, and make sure the table matches the one that was given in the original question.